So what do you have to do with this chart? Just fill it in, right? So we have the faster worker, we have the slower worker, we have the rate, we have time working together, and then the fractional part of job done. Fractional part of job done. I'm just copying it down right here. So it does, the rate is 1 over x. We have time working together, 2 and 2. Working together, 2 people can cut a large lawn in 2 hours. 1 person can do the job alone in 1 hour less. 1 person can do the job alone in 1 hour less time than the other. You know what? I don't like this chart. Let's make a better one. I don't like this one. Let's make a better one. Let's make it in line with the way we've been doing the other ones, which I like a lot better, which is you have the faster worker, the slower worker, right? You have the time to do job. And then in 1 hour, how much of the job? So time to, and then this is together. So time to do the job, how long does it take them to do it together? 2 hours, right? So in 1 hour, how much of the job do they do? 1/2. This is in line with the chart we did yesterday and the day before. I like this better. This is better than what the book was putting out there. So what does it tell us? 1 person can do the job alone in 1 hour less than the other. So if the slower worker's rate is r, the faster worker, how long does it take him to do the job? R minus 1. Yeah, exactly. So how much of the job does the slower worker do in 1 hour? 1 over r. And what about the faster worker? Yeah, I like this a lot better. So now what can you set up as an equation?
1 over
r minus 1, yep.
plus 1 over r
Equals?
1/2.
Yeah, exactly. That's what we did yesterday. Let's just stick with that. I think this is a little more, what they were outlining in the book is a little more convoluted. It's also what we're just more accustomed to. So in this one, what did I like you guys to multiply by? R minus 1 times r times 2, right? It's just the common denominator. So if you multiply that out, what do you end up with? You end up with r times 2 plus r minus 1 times 2 equals r minus 1 times r. Is that a quadratic? Is it in standard form? No, this should be pretty automatic by now. Not in standard form yet because we haven't grouped things. So 0 equals r squared. We have 4r and a negative r, so it's going to be minus how many r? Nope. Minus how many? 5r plus 2. Now you ask yourself, is that factorable? What do you think? Or nicely factorable? Because remember, everything is factorable. So in this case, what did we? Well, a was equal to what? 1. B was equal to what? C was equal to 2. So we have b squared minus 4ac, negative 5 squared minus 4 times 1 times 2. 25 minus 8 is what? Come on, what is it? 17? Sounds right. Now, when you get a discriminant like that, that's a good sign, right? Because if you'd gotten a really nice discriminant like 16, that probably means it's factorable because you have to square root this thing, right? So you end up with, and again, we're solving for r, right? So it's r equals negative b, so negative 5, plus or minus the square root of 17, all over what? 2 times 1 is 2. So our rate, how many rates did we get? 5 plus root 17 over 2, or what? 5 minus root 17 over 2. We've got 2 different answers for this one. Correct? So I know the other thing it says how to the nearest tenth. When it says to the nearest tenth, that probably means we're going to get an ugly answer. Do we actually get 2 valid answers on this one? Yeah, you get 2. The thing is, you couldn't have a negative rate. The thing is, the square root of 17, is that bigger or less than 5? Less than 5. So this is positive, and so is this one, right? So you'd actually have to find both and then see if they actually kind of make that you plug them back in to see if they test correctly. So you need your calculator. Do this for me right now. Use your calculator and tell me to the nearest tenth what each of these are. 2 answers. Solving for t, what should I do first? That's our goal, but what should I do first? Divide by. So we get d over k is equal to t squared. So yes, t squared is equal to d over k. So now what? So d is equal to what? Plus or minus the square root of d over k. but we don't like having a radical.
It's T.
D, sorry, T, sorry, T, sorry. So we don't like, so this is plus or minus root D over root K, right? But we don't like, so what do? Okay, like that. So what do we end up with? Plus or minus the square root of dk over k. So this would be your final answer right there. What kind of function is f? What kind of function is it? It's a quadratic, and it's in standard form. It just happens to be. Does it have to be in standard form? It could be a quadratic without being in standard form, exactly. So in this case, we have a quadratic. The question is, what does a quadratic look like when you graph it? Anybody know what that word is? It makes a what?
Parabola.
Parabola, right. So let's say this one right here makes this parabola right here. Parabolas are U-shaped. They can go infinitely up or they can go infinitely down. What are some important characteristics of parabolas, those of you that have seen them before? They can go through it twice. They can go through twice, once, or zero. Let's talk, hold on, go ahead. Yeah?
And their y-intercept is division of y-intercept.
They always have 1, yes. So for y-intercept, they always have 1. And for x-intercept, they can have 1, 0, or 2 of them. What can you tell me about the shape of that? There's other features on there that you might know about. Well, what? It could be. Well, there's going to be a positive or negative aspect, but what is this point called? Anybody know? Close. It could be the origin. It doesn't have to be, though. It's called the vertex of a parabola. And then this line right here, what can you tell me about that line? Yeah, it's called the axis of symmetry. What type of line is that? It's all lines are straight, yes.
No, this line is curved.
It's vertical. And why is it called the axis of symmetry? It divides it in half, but more than that, if you folded the board, if you folded it on that green line, what would happen to the parabola? It would line up with itself, right? So the axis of symmetry passes through the vertex, and it on both sides you have the same thing. It's a mirror image of itself. Mirror image of itself. So parabolas can go infinitely up or infinitely down. What do you think the definition of the vertex is? In this case, the vertex is the what point? Is it a high point or a low point? It's the lowest point. Lowest, and if the parabola is facing down, the vertex is going to be the or highest point. Is it possible for a parabola to have both a highest and a lowest point?
No.
For example, on this one, this has a lowest point. Does it have a highest point?
No.
No, it goes infinitely up. It goes infinitely up. Now, if it's facing downward, it'll have a highest point, but will it have a lowest point? No. So how do you go about, what's kind of our base quadratic? Our base quadratic is just going to be, let's say, x squared. If you wanted to draw a picture of that, many times you're just going to estimate it, but if you want to be a little bit more exact, you can make a table. When x is 0, what's y? 0. When x is, I don't know, negative 1, what's y? And when x is 1. What happens when you plug in negative 1? What do you get? Plug in 1, what do you get? What about when you plug in 2? Negative 2. Oh, 4 again, not negative 4. So if I plot these points, you end up with there's 1, 1, negative 1, 1, 2 4s right here, negative 2 4s right there. If you plot these and then connect them, is this a straight line in any way?
Nope.
No. So there's your base parabola. What we're going to do is graph lots of different parabolas based on this one right here. Based on this one right here. So my first question is, what do you think happens if I said, I don't know, g of x is equal to x squared plus 2? What do you think happens to that green graph right there? Anybody want to guess what happens to the green graph?
Up to the y-axis.
Actually, it can be more general than that. Yeah, this point goes up 2, that's correct. But is the vertex the only one that goes up?
No, the rest of
Everything goes up by 2. So this whole thing goes up by how much? 2. Goes up by 1, 2, 3, 4 right here. Goes up by 2. So if you add 2 to the outside, the whole thing goes up by 2. What happens if I subtracted 2? What happens if I said, I don't know, h of x was equal to x squared minus 2? What happens there? Down 2. So if you go down to, what does this one look like? Here, here, and there, like this. So if you want to move the function up or down, you add or subtract to the outside of the function. So if I added plus 4, the whole function would go up 4. So if you want to go down 4, you just subtract 4 to the outside. So this is up and down. We're going up and down now. Up and down. So what are the other two directions we need to contend with? Left and right. So let's say again, let's say I had a parabola. Say I had a nice parabola. Let's start with, I don't know, green again. So we have there, there, and there, and there. And again, what function is that? What's our base function going to be? Say g of x is x squared right there. So what happens, do you think, though, if I did this instead? And I kind of already set you up for it. But let's say instead I wrote g of x minus 2. So that's going to be x minus 2 squared. So I've subtracted 2 not on the outside but on the inside. Which direction do you think I'm going to move in? You think it's going to go to the right or left? So here's the thing. You absolutely are correct that in general negative is left and positive is right. Positive is up and negative is down. You think that positive is to the right and negative is to the left, positive is up and negative is down. In this case, it's the opposite of what you think. I'll explain that in a second, but I just need you to believe it for now. So if you subtract 2 on the inside of the function, 2 to the which direction? It does. 2 to the right. I'll show you. That's what I'm here to do. I'm here to help you with that. So the reason it does that, so in this case, all these points went over 2 to the right. And why does it do that? Well, think about it this way. You're subtracting 2 before you put the number in. Before you put the number in. So if I plugged in for x 4, what's 4 minus 2? So plugging in 4 into this one is the same thing as plugging 2 into the old function. Plugging it, exactly. So the new function, so 2 behaves like 0. 4 behaves like 2. 6 behaves like, so the whole thing moves over to the right 2. When you plug in 4 into here, what does it behave like? 2. When you plug in 2, what does it behave like? No, 2 minus 2 is 0. The point is this. All I need you to really focus on right now is it takes a little while to understand this, but on the inside, it's just the opposite. On the inside of the function is the opposite because you are subtracting or adding the number before it goes into the function. Before it goes into the function. Before. So what do you think happens if I did g of x plus 2 like this? It's going to be x plus 2 squared. You're adding 2 to it and then squaring it. Which direction do you think it'll go? So this went right 2. This one's going to go left 2. So I'll do this color right here. This one goes left 2, here, here, there, and there. So there it is right there. So which directions can we now move in? Up and down, left and right. Have we changed the shape of any of these? No. Shape has remained the same. Shape stays the same. Yes?
Can you show us, like, with plugging something in for x, or like the right and left ones? So, like,
what do we have to do? Go right 3, exactly. So let's do that. Right 2, thank you. So we go right 2. So here, here, here. There it is.
Is that the new one?
This is the new one right here. So this one right here, we went how far over? 2 to the right. So the final answer is that it's graphed right here as the green one right there. So what you can do, if you have a base function, you can move it left and right or up or down. Does this change any of the curvature?
No.
Is any of the curve changing? We're taking the same shape and we're literally just going either up or down, left or right. That's all we're doing right now. This, graph this one first. What does that look like? What function is that? That's y equals what? X squared. So at 0, when x is 0, what do you get? 0. When x is 1, what do you get? 2 squared is 4. So you have something that kind of looks like this. And it's a little easier for me because I have these like highlighters that are a little thicker. But as you found out, is it hard to draw a nice curve sometimes? Yes, it is. So what you should do is you could start taking these points. This is 0, 0. This point is 1, 1. This point is 2, 4. This point is negative 1, 1, and this point is negative 2, 4. So when you do this, what does that mean? Can someone tell me the two things you have to do? Left 3, down what? Down 1. So if you do that, let's just move one of these points. We move left 3 and down 1 to here, right? What point are we now at? Negative 1. Negative 3, negative 1. Negative 3, negative 1. You do that for all of the points. You do that for all of the points, and what do you end up with? You end up with an arc that looks like that. There, and you end up with an arc like this. So what are those 5 points going to be? What is this point right here? Sorry. This point went back 3 and down 1, right? So if you're at negative 2, 4, what's your new point right there? Left 3. Negative what? Negative 5 what? You went down 1. 3. Exactly. So you can take all 5 points. So you started with, what were your first points? Negative 2 and 4. That was your first point. Negative 1, 1, 0, 0, and 1, 1, and what? 2, 4. And you're going left 3 and down 1, so that's negative 5, 3. What does this one become? Negative 4 what? Negative 4, 0. What's this one become? Negative 3. You're going left 3 and down 1. Correct. This one goes negative 2, 0. And what's this one? Negative 1, 3. There are your new points right there. So all we've done right now is left, right, up, and down. There's one more type. There's one more type of transformation. What do you think happens if I gave you this right here? Let's say I gave you another parabola. Not packing up, right, Hannah? Ah, okay. So if I were to graph a parabola right here, here's our standard parabola. I'm doing the points again. So that function right there is y equals x squared. Oh. What do you think this looks like? Let's say I had j of x is equal to 2x squared. So I'm not adding or subtracting, I'm multiplying. What do you think happens? Do you think the shape is going to change?
It'll get.
Yeah. So there's going to be two things. We're going to call this steeper or shallower. Ready? Steeper, shallower. So do you think this gets steeper or shallower? It doubles all of the y values. What's double 0? So it stays there at 0. This goes to 2, and this is going to go all the way up here to like 8. This one goes to 2, and this one's going to go up here to 8. So what does this look like? It's really steep. So it's a little harder to draw that. Yeah, it's like this, right? So it got steeper. What do you think happens if I did this? Let's say n of x was 1/3 x squared. Is that going to get steeper or shallower? Shallower than x squared. So instead, what's this one going to look like? Well, it's going to vaguely kind of look like this. Shallower. So you can change the shape by multiplying on the outside. Change the shape by multiplying on the outside. Your homework tonight is in your syllabus.